Okay, I'm back, and now we're going to go to the lab that's entitled Linear Motion. So in this lab, you had a toy car that was rolling on the ground. And what you did was you measured the distance it traveled, and then you measured the amount of time it took it to go that distance. And you did it for like 5 different distances. And then you graphed it. So I would want you to know, what did that graph look like? So when you graph the distance versus time graph for something that's moving at a constant speed, what does it look like? So I could give you several graphs. Some graphs might be a line, and then others might be a curve, and then others, they might be straight across, and I could ask you which one represents an object that's traveling at a constant speed. Okay, then you should be able to find the slope of that graph. So slope is going to be rise divided by run. So it's going to be the up and down part, that's the rise, divided by the sideways part, that's going to be the run. And you need to pick out 2 points on the graph in order to find the slope. And then you ought to know what the slope means. So does it represent the speed of the object? Or does the slope represent the acceleration of the object? Well, it depends on what it's a graph of. So we did graphing in that particular lab. And then the second part of that lab was we took a ball and we put it on a ramp. So you should know what was the difference. So when that ball rolled down the ramp, how is that different than when the ball was rolling on a smooth, or the car was rolling on a smooth surface at a constant speed? Okay, and then how would you describe that motion? Okay, so that was the lab that we did on linear motion. So the next lab that we did was on Newton's second law of motion, which is, that would be a good test question. What's Newton's second law of motion? Force equals ma. Okay. This was one that we did on a computer. And one thing that you learned was how to add forces together when they are parallel to each other. So there won't be any of the thing where you have to add the arrows together head to tail. What I'm talking about is if you've got a force that's going this way with 100 newtons, and then you got another force that's going this way with 20 newtons, what's the net force? What's the sum of the forces? So it's not going to be 120, because this would be positive 100, but this would be negative 20. So when you add them together, you get 80. So that would be an example of something that might be on the exam. Okay, and then we did a lot with force equals ma. We showed that, for example, if you double the force acting on a box, what does that do to the acceleration of the box? So problems like that. We did problems like if you apply the same force to a light box and then you apply the same force to a heavy box, what happens? So what happens to the accelerations? We did problems like that. And then we also did problems where you put actual numbers into the formula. So if I give you the force in newtons and then I give you the mass, you could actually give me a number for the acceleration. Alright, the next lab that we did was on momentum, and that also was done on the computer. So what is momentum? So what's the equation for Momentum. You should know that. Okay, what does it mean to say that momentum is conserved? So what does conservation of momentum mean? Then we applied conservation of momentum to 3 examples. So we did it for an explosion where something was just sitting there, and then, so what was its momentum? 0, because it's not moving. Okay, and then all of a sudden one piece goes this way and one piece goes this way. And so if you know the mass of each of these 2 pieces, and if you know the speed of this one, you can calculate the speed of this one. So that was the explosion. Okay, then we did inelastic collisions. So that was the opposite of the explosion, where you got one piece that's going this way, and you got one piece that's going this way, and then when they hit, they stick together. And so, if you know the mass of this one and the mass of this one, and if you know the speed of this one and the speed of this one, then you'll know when they stick together what their speed is going to be. So check your lecture notes, because I do these problems on the lecture notes on the PowerPoint. So I encourage you to watch that, because a problem like that could be on the exam. You should also know just the basic definition. What happens when 2 objects collide elastically? And what happens when 2 objects collide inelastically? Okay, and I'm going to stop here, and then when we come back, we're going to do another lab.